Yeah, that's fine. Just make sure you make a pile on the desk. I want to regroup to make sure we're happily getting solutions to this. We'll stick around for 5 more minutes. I want to let you guys finish this. If you think it's going to take more than 5 minutes, take it with you and bring it back Thursday. I got no problem with that either. Okay? But I want to make sure a bunch of you are getting finished. I want to make sure that we are happily coming up with similar results here. So average. How many friends on average do my friends have? Sample average 470? 470 friends, okay? Average. Sample standard deviation?
Approximately 468.
Almost the same number. Pretty wild, huh? That surprised me. I'm like, holy hell, that's crazily varied numbers. 470 plus or minus 470. So then I say to myself, oh, I wonder if I can apply the empirical rule. I wonder if I can go 68% within 1, 95% within 2. So that's why I had you do the graph down here. And what did you notice when you drew the graph? Highly skewed data, yeah? Highly skewed. This is what I came up with. That's what, whoops. No, I didn't. I lied to you. I got an error. Let me fix that again. Well, I just did a zoom stat. I got that. As I finagled with the graph, because I'm a finagler when it comes to graphs, I started getting graphs that were more refined, kind of like that. But no matter how I finagled, I could never get rid of these dinosaur tails. It's like a Dimetrodon, for those of you who used to study dinosaurs like I do and my son does now. It's got this big fin and then this little tail flies off. The tail's going to be there. You can't get rid of the tail. That's the definition of skew, right? You got outlier data points in one direction. So the first thing I realize is when I get done the first page of the quiz is, maybe I shouldn't talk about the average. Why? On the back page? Because the data is skewed. I don't think anybody's going to look at that and call it a bell curve. It's like a bell curve that's missing the rest of its bell, which is skewed. If you take a bell curve with a pair of scissors, cut off one of the tails, it's not bell anymore. It's skewed now. So that was what I was getting at with that next question. Based on the histogram, list one reason you might not want to talk about the average and or the standard deviation, because it's skewed. That's when you shouldn't talk about averages, yeah? Good. Excellent. So then I said, let's pull back. Let's pull back. Let's simply look at percentages. Take a big step back. Let's bring in the idea of margin of error again. Margin of error. Because you guys were asking about that earlier. It's a great question. I didn't want to let it go. At the time I took this, I had 673 Facebook. I got those numbers backwards. I had 673 Facebook friends. I guess Facebook 673. So, what percentage of friends in my sample have more than that? 22%, 22%, 22%, 22%. You guys, what you do is probably counted them. And there were how many? 13 out of the 60? That's 22%. But now here's what you don't want to do. You don't want to say 22% of the population has more friends than you do. Why? Because it isn't the whole population, it's just a sample. That means you have to admit what?
Margin of error.
You have to admit that you need a margin of error. Yes, Lloyd, you must admit you need a margin of error. Now, I did the math for you and I calculated it. Based on a sample size of 60, the margin of error would be 10%, which is way bigger than anything you would see in a Gallup poll, for example. That's usually plus or minus 3 or 4. But that's because Gallup polls have huge samples compared to my little 60. They usually like 1,000, 1,500. So how do you take, I don't overthink this, how do you take that 10% and apply it to that 22%? Don't overthink this. Exactly, it's 12 to 32%. You add and subtract the 10% from the 22. So essentially what it does is, it does the same thing you would do with that empirical rule, but it applies it to that sample distribution. Some of you might be wondering, why are you doing that? You just told us it's not bell-shaped. There's a Math 244 principle acting right now. Who asked me earlier about margin of error versus standard deviation? Who was that? That was a great question. Andrea, thank you. There is something that happens when you convert from a standard deviation to a margin of error. It's called the central limit theorem. We'll talk about it at the end of this class, I promise you. That's what I was using right here on this little calculation. I didn't want to do the calculation for you because it doesn't make any sense. Yeah, soon. 5 weeks, maybe. That's why it's 10%. That's why you can add and subtract it. So therefore, we can reasonably say the percentage of all my Facebook friends that have more friends than me is between 12% and 32%. It's at least 12% and at most 32%. That's what fills in the little bars there.
Good job.
And then it says, if you look at all my friends' friends, you'll see that about 24, means if I actually went into the entire list and counted up the number of those that had more friends, it was 24% of my list. Is 24% between 12 and 32?
Yes.
And that is why you have to have a margin of error. You were wrong when you said 22. You were off by 2%. But when you put the error bars on there, it's like taking your net and spreading the net wider. More likely to capture what you're looking for. Does that make sense? If it doesn't, don't worry, take 244 with us. It'll make a lot more sense then. But that's why you need, that's why you need a margin of error, to make sure that you capture the parameter you're looking for. Is that fair? And I think we just answered the last question too. Why must the margin of error be attached?
Make sure you capture the...
Right! Because you have a sample, there's uncertainty in your sample. The margin of error decreases the uncertainty.
So to make sure you capture the sample?
Let's say to make it more likely you capture the sample. You're never 100% sure. You're never 100% sure. There's always a chance you're going to miss it. But by putting a margin of error, you're less likely to miss it. Does that make sense?
Yes.
If you put something as simple as because you have a sample and not the whole population, I'm totally down with that answer. It's a mechanical answer. I love that answer. Please.
This just says everyone's name is hot, so you only need one.
I only need one quiz for the group you're working with. That's totally fine. Just make sure all your names are up there, yes? Cool. If anybody needs more time, just bring it back Thursday. But if you were able to get it all done today, let's go ahead and drop the file right here. Call it good. Yes.
I wrote them down on a scratch paper. I wrote it down here, so that all we have to. You have to write them on that since that's what.
Oh no. You didn't even understand where that came from.
We gotta do
That's
this.
okay. For a scientific journal.
Well, yeah, no, that's good. You wrote the right answer down.
Yes. All you gotta do is remember how to apply it. It's all good. Make sure your name's on there. It's all good. We got it all squared away. Excellent job. Thank you guys. Hopefully today was an enlightening experience.